Hi everyone. Okay, in the previous session, we've discussed about how to determine the regression functions with manually, yeah, in terms of how we can determine the value of B0 and B1, yeah, using manual calculation using Excel. Yeah, one thing that have to be kept in mind is that the resulted, the n regression function results will provide the best prediction, yeah, if the range of predictor or independent variable is inside your sample data. Yeah. So let's go back to our previous example. Yeah. So here we can see, yeah, we have the regression function here. Yeah, 5.82x plus 910. Yeah. Uh, yeah, the regression, and we see that our data set, yeah, the independent data set, the minimum value is 23 here, yeah, around here, and then the maximum value is about 99. Yeah, so the range of data is 23 and 99. Yeah, and this regression function, yeah, will provide the maximum prediction power if we do prediction within the scope of within the range of data. Yeah, for example, we have 23 and 99. Yeah, so if we want like to predict how much is the sales will be if we have a 50 million budget rupees budget, or maybe 80 or 25, which is still within the range of the data, it most likely that the prediction function will provide the maximum performing predictions. Yeah, but if we try to predict the sales, yeah, using an X budget value of which is outside of the range of prediction, which means extrapolation. Yeah, this case is called extrapolation. Extrapolation is try to predict something with expanding the scope of data that you have. Yeah, if you do extrapolation, then the prediction power will likely to be will likely to drop. Yeah, so make sure that you do interpolation instead of extrapolation, yeah, in using this regression function. Okay, so now let's discuss about coefficient of determination. Yeah, coefficient determination, or R square, is a specific value that you use to measure how good your regression function is. Yeah, or in other words, to be precise, the coefficient determination describes the portion of total variation in dependent variable that is explained by the variations in independent variable. Yeah. So what to explain this more clearly, I will use this illustration. Yeah. Yeah. So suppose you have yeah, you have this data set, yeah, dependent variable of y, I, and then independent variable of x, yeah, and then there is cases in which, you know, when people have a specific data set like this. Just a moment, yeah. So you have an ads budget record for 12 months, and then you have sales budget of sales performance of 12 months. And then, for example, the owner would like to predict how much sales he will get in the near future. And most of the, not most of the time, many times, yeah, the decision maker uses the mean value of the previous performance as the predicted value for the future. Yeah, so the simplistic method is used as a reference. Yeah, so for example, if you, so this is the record, yeah, the sales record from the previous example, and then you have a mean value of 1.2 billion rupees, yeah, the monthly sales, and then the owner can use a simple method. Okay, for the next month, the following month, sales will be 1.2 billion rupiah sales, yeah, according to the average value of sales from the previous months. However, If we use only the mean value, yeah, here, yeah. So here is the mean value. So this is, for example, function A. Yeah. So we use the mean value to predict the actual value. Yeah. Then we will have a prediction error of SST, yeah, or total sum of square, which means yeah, SST reflects the deviation between the actual value and the mean value. Yeah. So this is the the error that you will get if you predict future outcome based on the mean value only. Now the question is, okay, so I have method A, which is using the mean value only. If I use linear regression, yeah, how will my prediction be improved? Huh? So if we use, so I use another ink in color, yeah. So if I use regression, for example, like this, yeah, we see, yeah, the predicted value will be like in here. Yeah? This is based on the regression function will recommend the predicted value here, yeah, to this value, which means that the predicted value becomes closer, yeah, to the actual value rather than if we use the mean value, yeah. So here, yeah, and then the question is, yeah, what is the degree of improvement, yeah, if I use regression value compared to the if I use mean value? That is the basic intuition of R squared. So R squared basically, yeah. So basically is a apa is yeah, is reflecting, yeah, the proportion of error, the improvement of prediction accuracy that is caused by the regression function, which is y bar, yeah, y hat minus y actual. Nah, yeah, this one. If I compare that with using, sorry, this is, yeah, sorry, I will repeat my explanation. Yeah. So the coefficient of apa coefficient of determination basically is, you know is a proportion of how good the improvement will be if I use regression. Yeah, which is, so it's calculated by y hat minus y bar. Yeah. Compare if I use the prediction using only by the mean value only. Yeah, so this is y I minus y hat. Yeah, and then I square this. So the intuition is like that. Yeah. So it measures, yeah, it measures the improvement of the regression, the prediction improvement of the regression value compared to if I use predictions using the mean value only. Yeah, that's the intuition. So if you can see, yeah, basically, so if I use the mean value like this, yeah, so let's say that this is A. Yeah, if I use regression, then it will be improved by B. Yeah, and then R squares is actually, yeah, R square, yeah, uh, related to the how good the improvement that I will get if I use regression divided by if I use only the mean function approach. Yeah, uh, in detail it is written like this. Yeah. And of course we have the remaining, which is the error, the remaining component is error, which leads to A equal to, yeah, or SST equal to SSR plus SSC. Yeah, this one. Yeah. Okay, so now how to calculate R square actually? Yeah, so now I would like to demonstrate how we can calculate R square. Yeah, using Excel manually. Yeah. So okay, so here we have the Excel sheet, previous Excel sheet. Now I would like to copy copy the function in the Excel so we can see it clearly. Yeah, so R square equal SSR divided by SST, and then the functions I also copy here. Will copy here. Okay, let's calculate R square then. Yeah. Okay, so first let's calculate SSR first. Yeah, SSR equals to the predicted value of regression minus the mean value of the I. Yeah, so the predicted value from the regression. Yeah, y hat. Oh, we haven't calculated. Yeah, so I will put it here. Yeah, so this is y hat. Yeah, which means the predicted value of the sales if you use the regression function. Yeah, so now we have the regression function equals to this. Yeah, B0 plus B1. Yeah, this is B1. Yeah, multiplied by the independent variable. Yes. Yeah. So, okay, now we have the predicted value, right? Yeah. But the problem is in SSR we need, okay, so we have that. Yeah. Okay, we have the predicted value of each, and then what SSR would like to have is, so I will just a moment. Oh, what SSR would like to have is, just copy the formula here. Yeah, sorry, just a moment. Quite long process. Yeah. So we need to have a y hat minus the mean. Yeah. So moment I need also to copy this. Yeah. So here, yeah. So they need the predicted value, the minus by the mean value. Yeah. So this, the mean value of the actual apa namanya, actual sales value. Yeah. So equals to this minus the mean of the actual sales value, which is this, right? Let's see. Is it right? Just a moment. Sorry, this divided by, no, this is a summation. Sorry, I should put this. So this equals to this, yeah, and then divide minus by the average value as y bar, which is this, right? This seems right. Okay, so I put both in it, yeah, and then I have to square it, right here, SSR equals this, and then I have to square it. Then, yeah, I just do the squaring, and of course I have this. Yeah, and then what SSR is making a summation out of all the square difference between the predicted value and the mean of actual dependent variable value. Yeah, so to sum, so here we have the SSR. Okay, and then for the SST, or total sum of square. So let's copy the formula here, maybe. SST. What does it need? Yeah, it needs, okay, the actual value, the actual value of the dependent variable minus the mean value of the dependent variable. Yeah, so I will also make a copy here. Just a moment. Yeah, so what I have to do is, make a subtract the actual sales value with the average value for each component. Right, and then I drag and drop to the down. Yeah, and then after that I square this value. Right, and then I drag it down and then make a summation out of it. Yeah, just like this. Then we have SST. Yeah. And then of course the R square is easy peasy, right? Put here R square equals to SSR divided by SST. SSR is this cell divided by the SST, which is this. Then the coefficient variance of variation for our regression function is 0.06. Yeah. So I think that's the coefficient of variation. Yeah. So I've demonstrated how we can calculate it manually. But of course, after we understand the philosophy, of course, a lot of data processing softwares also, data analysis software also provide embedded function. Yeah, if you want to see the R squared, then simply click the line, the regression line, and then go to format trend line, and then you display R squared value on the chart. Here we are. Yeah. So based on the Excel calculations, the R squared equal to 0.6066, which is equals to our calculation. Yeah. So that is how you determine the coefficient of determination, for the regression value. Yeah. So okay. Yeah. So what does it mean if based on the function, the R square is if the regression the goodness of the regression function is, of course, if we can predict that the prediction value is close to the actual value, which means that the improvement in SSR is close to the SST, if it's really perfectly, if our regression function can perfectly predict the actual outcome, then the R square will be close to 1. But if our regression function performs badly, which means it has very little improvement if you compare it with the mean function mean approach only, then the R square will be close to 0. So as so R square means that perfect relationship between X and Y. Which means also 100 variations in dependent variable is explained by the variation is independent variable. Yeah, but usually the perfect linear arrangement like this is rarely happens. That's why here we can see, yeah, you have usually the data of scatter plots usually looks like this, but you know, if this data set is closer to the regression line, yeah, and then converge to a thin line of a spread, then the R square is likely to be higher than the data set that is spread have a large spread, yeah, or really volatile. That's why. And R equals 0 means that the improvement, that we get is, yeah, we have uh, no competitive advantage in using regression instead of the mean. So the SSR is equals to the yeah, the predicted value using regression is equals to the one that if you use the mean value, which means that, you know, R squared will be equals to 0, yeah, which means that there is no relationship between the independent and dependent variable. So how it's no matter whether you enlarge the advertising budget or you give no advertisement budget, the sales value will be pretty much the same. Which means that, you know, there is no relationship between the sales performance and the advertisement budget you give. Yeah. I think that's it for now. I hope you can enjoy all of the 3 videos of the unified regression. So good luck for your final exam. See you later on. Bye.